pleasure to be here with you also in this terrible particular moment, and I'm happy that also in this strange way, so in distance mode, we are able to perform this degree exam. First of all, I want to thank the students, the graduating student, the member of the board, and the supervisor and the opponents that is present now, and thank you also for their work. Okay, now I don't want to continue to speak in general, and I prefer to start with the session, and I asked to the first student, for the first student that have to present, that is Mattia Sala, to switch on the camera and the microphone, and then we can start. So I change. Okay, now you are able to start. And first of all, I have to identify you. Yes, you are Mattia Sala. I identify you, so you can consider to share your desktop and start with your presentation. Thank you.
Okay. Okay, it's all okay. Do you see my presentation?
It's working? Yes, it's working. Don't worry.
Okay, good afternoon. My thesis work regards the mechanical characterization of the masonry in Valtellina. This is the thesis outline, and it represents the points of the following discussion. So let's start with the first one. Basically, in Italy, there are two codes which regard the existing masonry. The one on the left is a guidelines related to the building subjected to the cultural heritage, while the one on the right, the ministerial decree of 17 January 2018, regarding the masonries, it defines into a table the mechanical properties divided into six six categories according to the texture. An important point is that the code itself entrusts to each region the possibility to define better values for the mechanical properties of the masonries for homogeneous zone, such as the Valtellina. For this reason, the aim of my thesis work was to better define the mechanical properties of the Valtellina masonries with respect to the one given by the code. The data are collected through NDTs and MDTs tests, which some of them are performed directly by me and on site, and some of them are taken from the database of an engineering society which work on the territory. The tests are the following ones: the single flat jack to determine the stress state inside the masonry, the double flat jack to determine the compressive strength and the deformability modules, penetrometric test to evaluate the quality and strength of the mortar, sonic test to evaluate the quality homogeneity of the section, corings and video endoscopies to evaluate the thickness and the section of the masonries. And these are some of other tests performed by me. The territory of study, as said before, is the Valtellina, which is a region placed in the center of the Italian Alps. It followed the flow of the river Adda from the source in Livigno to the mouth in the High Como Lake, plus the region of the Val Chiavenna, which follow the Mera and Lido stream. The whole region is placed on the Swiss border on the north side. The geologic point of view is really important as we speak about stone and mortar masonries. And Valtellina is placed in the western area of the Alps, which is characterized by silicate rocks. And moreover, it's placed along the Tonale Fault, which is an imposing tectonic. And for these reasons, the most widespread lithotypes of Valtellina are the metamorphic ones. The constructions are, of course, influenced by the territorial context in which they are inserted. And for this reason, the stone had a predominant role in the constructions of Valtellina, starting with the dry stone ones and the now famous terraces, arriving to the old typologies built with stone and mortar, such as the rural houses, the palaces, the fortified structures, and the churches. The masonry is a composed system which is made out of stone and mortar. According to different stones, there are also different masonries related, and I've identified 3 types: the rough stones, the rough hewn stones, and the cut stones masonries. The first type, the stones are taken directly by nature or splitted by the erratic boulder in the nearby of the constructions, and they are characterized by a polyhedric form. The second type is similar to the previous one, but the stones are literally processed to obtain a better shape. The cut stones come generally from hard rock, which have a good capability to be processed into parallelepiped elements. The mortar. The Valtellina territory is characterized by a scarcity of calcareous outcrops, and the main one is the one of the main Dolomia in the area of Bormio. On the other part of the territory, there are only localized outcrops, where generally also the lime cling was built in the nearby, such as this example in Madesimo and this one in Grosio. In literature, there are some analyses regarding the analysis on mortar sample, and it's found that the binder aggregate ratio is really low, highlighting also in this case the scarcity of the availability of the mortar outcrop, the calcareous outcrops. Construction techniques. It's really important in the analysis of the construction techniques the role of the dry stone, and thanks to the similarity between the dry stone and the stone and mortar masonries on the Valtellina territory, the lack of information regarding the construction techniques of the stone and mortar masonries is partially recovered thanks to the ones found in literature regarding the dry stone ones. And some points which are in common between the two and identified as fundamental are reported in the following points. The first one is the stone balance, and it means that each stone has to be supported from at least 3 points to be in equilibrium, like a common rigid body. The next is the joint crossing, which means that the alignment of by placing the stone courses, the alignment of the vertical joint have to be avoided in order to avoid the formation of weak points. The horizontality of the stone courses, which help to distribute the vertical loads, and we will see later that it is an important point to evaluate the mechanical properties of the masonry. The presence of transversal connections, which in this case the trough stone, which in the case of a multi-layer walls, it links the various layers, and it's important to promote the monolithic behavior of the wall itself. And the last one is the wall crossing, where in the corner the stone of orthogonal walls have to be placed in a proper manner to promote the box behavior, which for masonry construction is fundamental to sustain the horizontal actions. Passing to the sections, we see that on the case studies, the mean thickness detected is 67-68 centimeter, which is in line with what found the literature regarding an analysis of the Valtellina churches. And moreover, there's a feedback in a marble plate hanged in Tirano reporting the measure of the arm, and this measurement of 67-68 centimeter, the arm is the only one that was used, or better, is the main one used at the time for sizing the masonries. Analyzing instead the masonry in the elevation, we see that the mean quantity of mortar for the case studies is 34%, which also in this case is in line with what found in literature regarding the masonries of Lombardy. But in any case, this is only a qualitative value, as the quantity of the mortar should be evaluated in the section. To deepen the analysis regarding the construction techniques, I have analyzed 2 case histories, which are the Masegra Castle in Sondrio and the Sant'Ignazio Church in Ponte Valtellina. For both of them, historical and material analysis were performed, and also corings on both foundation and elevation walls, and mechanical properties analysis. And some points are stated. The materials are from a strictly local origin, with a prevalence of metamorphic rocks. There is a scarcity of use of mortar. The masonry of Sant'Ignazio Church were built mainly with a disordered texture, while the ones of Masegra Castle are both with a disordered texture and with rather horizontal courses. And the mechanical properties will be discussed in the next points. Passing to the data analysis, the case studies are widespread on the whole Valtellina territory, and the data coming from the various tests are collected into data sheets, and which are organized as follows. Building description with photo, position, historical and structural description, and surveys. masonry description, both in section and in elevation, flat-jacks, position, data, graph, and results for both single and double, corings, position and results, sonic test, position and results, penetrometric test, position, data, and results. And moreover, for each case studies, summary data sheets were performed. According to the Italian code, among the tests done, the flat-jacks are the only ones suitable to directly determine the characteristics of the masonries, and by correlating the deformability modules calculated on the first loading step and the elastic module on the unloading step, we see that there is a good value, a good linear correlation, apart from some data highlighted with a letter. And considering this as anomalies and removing from the data set, we arrive to a better value of with an R-square of 92%. And for this reason, the deformability modules are the ones used for the following analysis. So the next step was to search for some matching between the mechanical properties of the masonries and some circumstances which could be relevant for the buildings. The first division was among the construction typologies and performed between churches, public buildings, and palaces. In both cases of the stress-strain graph on the left and the deformability modules graph on the right, the data are really scattered and there's no proof, there's no highlighting or of classification or relationship between the data. Going on and dividing the construction according to the period between 15 and 17, 19 and 20 centuries. Also in this case, the data are really scattered and no classification is highlighted. The last one was according to the construction location between Valchiavenna and Lake, lower, middle, and higher Valtellina, but even in this case, the data are really scattered, highlighting no classification or relationship between the various tests. So the next step was to try to correlate the various tests performed. The first one is the flat-jacks and sonic test, and the deformability modules graph versus the deformability modules versus the sonic wave velocity on the left graph. Both in the case of linear and parabolic correlation, there is a scarcity of correlation or relationship. And regarding instead the graph on the right, the stress state versus the sonic wave velocity, there's a better value with an R-square of 70%, but in any case, this is not a useful result that can be used for the next analysis. In the case of the compressive strength versus the sonic wave velocity, also in this case, there is a scarcity of relationship between the data. Going on and analyzing flat-jacks and penetrometric test, we see that the lack of correlation highlights the fact how the mortar is not the strength of the mortar is not a useful parameter to evaluate the properties of a masonry, and also adding the parameter of the mortar quantity evaluated and showed before, the scattering of the point is really high. The last one was the correlation between sonic and penetrometric test, but even in this case, there is a poor value of relationship. This is due also to the fact that the sonic wave propagation is really influenced by the difference between stone and mortar. The next step was to plot the graph of frequency of the deformability modules, and we see that there are a lot of values higher than 5,000 Newton over square millimeter, which are really stiff masonries and considered anomalous. And removing from the data set is already visible a sort of classification of the masonries according to the deformability modules. And according to this hint, I performed a division of the masonries according to the texture into two typologies. Type 1, masonry with disordered texture, and type 2, masonry with rather horizontal courses. By performing the mechanical analysis of the two typologies for what concerns deformability modules and the compressive strength, the classification performed proved to be effective, as in both cases the mechanical properties of the masonry classified as type 2 are better than the one classified as type 1. Regarding instead the stress state, the two values are quite similar. So in the end, the mechanical properties of the two typologies, the mean mechanical properties, are collected into a table with 25 reference tests for type 1 and 15 reference tests for type 2. The last point was to search for some feedback. The first one is with the comparison with the Italian code, where the limits of compressive strength and versus deformability modules given by the table are reported inside this graph. And from the point of view of the compressive strength, the values of the Valtellina masonries are in line with the ones given by the code, while regarding the deformability modules, the Valtellina masonry proved to be stiffer than the limits given. And this is a good point, as the aim of the thesis was to better define the value of the mechanical properties given by the code itself. The next comparison was with the case histories, and regarding Masegua Castle, dividing the masonries according to their texture. This classification matches also in this case with the mechanical properties, and this is confirmed also by the compressive strength versus the deformability modules graph, where the mean values are matches with the mean values highlighted for the type 1 and type 2 of Valtellina. The comparison with cases, the Sant'Ignazio, only indirect tests were performed with sonic wave velocity and the penetrometric test, and the mean values found are in line with the values found for the typology 1 of Valtellina. And moreover, we see the masonry is was made with a disordered texture, and for this reason, the mechanical properties of Sant'Ignazio churches can be taken with a good approximation similar to the typology 1 of Valtellina. The last comparison was the one with other masonries coming from another alpine context, in this case in Rovereto, Trentino Alto Adige. And looking to the masonry texture, it's really similar to the typology 2 of Valtellina with rather horizontal courses, and these similarities are highlighted also in the case of the mechanical properties in the table below, where the values of the Rovereto masonries in typology 2 of Valtellina matches. And this is highlighted also by the compressive strength versus the deformability modules graph. This is also a good point, as the masonries of Rovereto are built with calcareous stones, while the ones in Valtellina with the metamorphic, highlighting how the main parameter to consider for the evaluation of the mechanical properties is the masonry texture rather than the stone type and the mortar. So, arriving to the conclusion, these are the points stated inside my thesis work, and the Valtellina masonries are built with a prevalence of metamorphic rocks, and with complex techniques, which means that the stones used are mainly rough or rough-hewn, and the mechanical properties of the masonries are reported inside this table. And I want to conclude with a picture of my hometown. If you focus on the building, this picture from 1920, passing to 1950, and arriving today, we see that the masonry buildings, even after a century, they are still standing, and they are even today inhabited. Thank you for your attention.
Thank you very much. First of all, I asked to the opponent if he has some questions.
Hi, here I am. Okay, I have one question for curiosity. Did you have also the opportunity to perform some tomographic analysis by using sonic technology?
No, tomographic, no, only indirect and direct test, but I've seen some of them, and I have some of them inside my database.
Okay, and one observation is that you did some comments about the reliability about sonic test results, and in my opinion, you can also stress some limits regarding other tests. For example, you did also some penetrometric tests on mortar joints. Yes. The question is, did you try to do the test along the visible surface of the wall, or also in deepness?
I tried only in the visible survey. If you mean, I tried both indirect and direct tests, so on the surface and also on the regarding the section of the masonries.
Okay, this is one point, because I appreciated the correlation. It reminds to a previous one of the first work I did for the university, and with similar results. And it is interesting that the section of the wall, in my opinion, is the key point. According to your experimentation, is the internal part of Valtellina walls very similar to the texture. You can see the one that is visible. You can analyze, or you have met some typologies with a nucleus that is totally different from outside.
In most of the cases in which the data are at my disposal, the nucleus are really similar and well, let's say, interlocked with the masonry layers. But I have not analyzed very much the nucleus of the walls. I don't have a lot of data regarding the nucleus of the walls.
Okay. I also see that in the end of your consideration, you also underline that this is correct. And the point is that, in my opinion, for sure, there are several limits by using direct sonic tests. But according to another limit coming from flat jack tests, that is the fact that the device cannot enter in depth inside the wall. In some cases, the combination, the complementary use of both results can show a better interpretation of the result. This is a point that, in my opinion, could be emphasized in your research. This is just one of the main observation I wanted to have. For the rest, I think that the work is solid, and I really appreciated the large amount of experimental data you were able to find and to consider. So for me, is enough. Thank you.
Thank you.
Thank you very much. Other questions? Okay, if we have no other question, I thank you very much, Mattia Sala, and then we can continue with the next students. Okay.
I have to stay, or I can go and come later for the...
What is important is that you have to be present at the end when we make the proclamation. Okay.
Okay. Okay. Thank you.
For all award. Okay. Bye.
Thank you. Bye.
Bye. Bye. Okay. The next one is Andrea Sabatini. Okay. So now Andrea Sabatini is able, so he can consider to switch on the camera and the microphone.
Can you hear me? Good afternoon.
Yes, but I cannot see you.
I switch on the camera.
Okay. I identify you because I have your ID card. And thank you very much. So you can consider to share your desktop and start with your presentation.